Hello everyone, let's take a look at our next problem. If every term in a sequence S is defined by the sum of every item before it, give a formula for the nth term. Okay, so this is kind of like, it's almost like the definition of the Fibonacci sequence, except you don't just add the previous two terms, you add all previous terms. And it doesn't tell us what the first term is equal to. So we need to initiate the first term of the sequence, otherwise things aren't really well defined. I'm going to assume that A1 is equal to 1. Then A2 is equal to 1, A3 is equal to 2, A4 is equal to 4, A5 is equal to, oh, look at this. Does this make sense? This should make sense, right? Like, I mean, this needs to be proved, right? I'm just stating this after writing the first 6 terms of the sequence, but it's pretty clear that this pattern is going to continue. Well, let's just go ahead and prove this, right? What's the best way to prove this? I suppose some kind of induction. So assume the formula holds for k less than or equal to n. Show it holds for n plus 1. Okay, well, n plus 1 is the sum of a k for k going from 1 up to n. This is equal to 2 to the k minus 1, but we need to start k at hold on, is this the right number that I want here? Do I want n minus 1? When n is equal to 3, I guess this should be a minus 2, right? Yeah. This should be a minus 2. So k minus 2, but this is for k going from 2 to n plus 1. Okay, so this is okay. And this is just a geometric series. So there's a formula for that. What is the formula for the geometric series? I think it is x times 1 minus r to the n over 1 minus r. We might need to, okay, I'm going to just, it's something like this where x is the first term in the series, r is the common ratio, and n is either the number of terms or the number of terms plus 1, something like that. But I'm just going to derive quickly here the formula for a geometric series, and what I'll do is I'll do it for this very specific form of geometric series. Okay, so we're done now. This all ended up being, fairly straightforward. Really helped to just write out the first few terms in this sequence. The pattern was pretty easy to spot right away, and if you know that adding up powers of 2 gives you another power of 2, then it's easy to convince yourself that this pattern holds, and then it's just a question of proving it. But yeah, everything you need to show this is here. And I suppose the one thing that we have left to sort of deal with is if the first term were not equal to 1, but if the first term of A1 is equal to, let's say, a constant C, then all of the terms down here are also just going to be multiplied by C. And you can see that, for example, by saying A1 is equal to C, then A2 will be equal to C, A3 will be equal to 2C, A4 is equal to 4C, and so on. Yeah, so this was, I guess I didn't expect this right off the bat, but writing this out and then a simple proof by induction makes everything fall together. Thanks for watching.